All right, team, here we go with section 1.1, angles. So first of all, there's a lot of vocabulary here that you need to get copied down and a picture here taken from the book. So you can pause the video and copy this stuff down. And honestly, it's not going to make much sense copying the words down. I feel like vocabulary definitions in math usually don't until we actually put it into action and do some problems where they actually come into play. So only one other thing I want you to add to this quadrantal angle thing down here is that these can be 0 degrees, 90 degrees, 180, 270, 360, etc. Okay, so you can pause and copy that stuff down if you need to. I'm going to jump right into the very first problem, the example problem, which has to do with drawing, which is kind of fun. So it says draw 35 degrees and label the initial side and terminal side. Both of those words are vocab words, so you need to be familiar with them. You can see the definition above. But for 35 degrees, so we're not just drawing like we did in geometry, a random angle with two rays sticking in whatever direction. What you have to think about here is an actual coordinate axis. So a coordinate axis looks like so. And this is 0 degrees, and up here is 90 degrees. Okay, so 0 degrees is always on the positive x-axis. That's what this is down here, positive x-axis. You know, this is the y, this is the x, you remember that part, but the positive x-axis is in this direction, negative x-axis is in this direction. Anyway, so if I'm going to draw an angle of 35 degrees, that means that my first ray is going to be here on 0 degrees. And for my angle to be 35 degrees, I need a second ray, and that would probably be somewhere in here. So I rotated that direction 35 degrees. It says label the initial side and the terminal side. So initial means beginning, and this is the initial side. Terminal side is where did it end. And that, in a nutshell, is your vocabulary for initial and terminal and how to draw your very first angle. Congratulations. Draw a coterminal angle with 60 degrees. Okay, that seems a little bit interesting. Coterminal is another vocabulary word. Okay, so I'm going to first draw 60 degrees. I'm going to extend my axis just a little bit. 60 degrees starts here. And let's see, if this is 90, then I need to go 2/3 of the way up. So here. That's my 60-degree angle. So again, my initial side always on 0, the positive x-axis. Terminal side, 60 degrees, stops short of 90. And okay, so coterminal means the same exact position but differs by 360 degrees. So that means that I have to go around the circle 360 degrees and end in the same place, which is kind of weird. So starting here, going around a full circle, which is 360 degrees, and ending here. Okay, so how many degrees would that be? I did a full 360, which took me to here. So I went 360 degrees and another 60. So the math is, you know, pretty self-explanatory. 360 degrees plus another 60 degrees. That means that my red angle, which is coterminal with 60, would be 420 degrees. So that is a coterminal angle with 60 degrees. I could have gone around the circle again, another 360 degrees, and gotten another coterminal angle. All right, so moving on to the next page. Here's some weird looking stuff. Okay, so we need to learn some new symbols. Start with number 3 here. So we have 51 degrees, 29. This thing is called a minute. It's a little apostrophe, but this would be 51 degrees, 29 minutes. Plus 32 degrees, 46 minutes. So you guys, this is really similar to adding minutes and hours and seconds and stuff like that. So what we have to do, we're going to learn how to do this by hand. So the way that you learned how to add numbers in elementary school is the way that we're going to start adding these together. So I'm going to bring out down the 32 and 46 down here to keep everything lined up. And I'm just going to go ahead and add carrying ones and blah, 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 the same way that we've been doing this kind of thing for years. So 9 plus 6 is 15. Carry the 1. That gives me 7. And this is minutes. And 1 plus 2 is 3. Bring down my degree symbol. 5 plus 3 is 8. So 83 degrees and 75 minutes. So this is not considered like complete, I don't know, it's like reducing fractions, I guess. Kind of a weird way of looking at that. 75 minutes. How long is 75 minutes? Can you like think about that in your head in terms of time? That's 1 hour, 15 minutes. Isn't that like a better way of saying 75 minutes? So the way that we're going to write our final answer is, instead of saying 83 hours, even though it's degrees, instead of saying 83 hours and 75 minutes, I'm going to change that to 84 hours, or degrees, and 15 minutes. And that is our final answer for that one. Kind of weird, right? You have to think about it in terms of hours, minutes, and seconds. We'll get to seconds also in the next problem, actually. I'm going to skip number 4. I want to talk about that one in class, but I'm going to go right to number 5. Convert 74 degrees, 8 minutes, 14 seconds, yes, that is the seconds notation, to decimal degrees. So this is kind of a weird thing, but all of these are going to be done similarly. I'm going to just do one quick example with you to show you how this works. But 74 degrees, and in order to convert it to decimals, what we need to do is we need to change this 8 minutes into a fraction, which is 8 minutes out of 60 minutes in an hour, which is kind of weird. And then same thing with seconds. We have 14 seconds. How many seconds are in an hour? 3,600. Okay, so I'm going to write a little bit of stuff. 60 minutes per hour. And in this case, there are 3,600 seconds per hour. That's where those numbers came from. And this is how we're going to convert degrees, minutes, seconds into decimal degrees, which is kind of weird. But now you just go to the calculator. 8 over 60. Well, I'm going to bring down my 74 first. And that turns into 74 point, the degree does. I'm going to be adding 8 over 60, which is 0.13 repeating. And 14 over 3,600 is 0.0038 repeating. And so I just have to add those three numbers together, which is weird, I know, but it's 74.13, and I'll just round up to 3 decimal places, 0.137. So kind of weird, but a new phenomenon that we need to be starting to think about in this class, okay? The next one is having degrees, minutes, and seconds, and converting it to, or having degrees in decimal form like this, converting it to degrees, minutes, seconds. So this is also kind of weird, but our whole number is going to stay the same here. It's going to be 34 degrees, and I need to go backwards. Remember how I took the minutes part of the last problem and divided by 60? So in this case, what I'm going to do is I'm going to take the decimal, I'm kind of truncating it, chopping it off, and multiplying it by 60. So it's the opposite of dividing by 60, which we did in the last one. And that gives me 49.02. And so that means I now have 34 degrees, 49 minutes, and again, I'm going to cut off this part, and that's going to become my seconds. So I need to do 0.02 times another 60, because there are 60 seconds in a minute. And that's going to give me my final answer, which is 34 degrees, 49 minutes, and 0.02 times 60 gives me 1.2, which I'm just going to round to 1. So you round to the nearest minute, the nearest whole number. So this is 1.2 right here. I'm just rounding it to 1. If it was 1.9, I would round it up to 2. Okay? So that is how you convert decimal degrees to degrees, minutes, and seconds, which I know is kind of crazy and weird. But those two problems are brand new, and a skill that we're going to have to do continually throughout this class, okay? So I'm going to breeze over that again really quickly just to show you the difference. This is a degrees, minutes, seconds, and in order to convert it, I take the degrees as my whole number, and that stays my whole number in my answer. But to get the decimal part, you take the minutes and divide by 60, and you take the seconds and divide by 3600. And you just add those two decimals, like kind of squish them together onto the same problem, and that gives you 74.137. To go backwards, you still take your whole number, and that stays your degrees in your final answer. But I need to take the 0.817, the degree part, and you kind of chop it off, and you first multiply it by 60, and that gives you another whole number, so that becomes your minutes. And then this decimal you need to multiply by 60 again, and 60 times 60 is where the 3600 comes from, if you're a little bit confused about that. I'm multiplying by 60 and then by 60 again here, which gives me the 3600, which is over here in this area. So then I'm taking this decimal, 0.02, multiplying it by 60 again, and that gives me 1.2, so I'm rounding that final answer to just 1 second. Okay? The last thing I want to talk about is these coterminal angles down here, so 908 degrees. Maybe you have an idea of where we're going with that 908 degrees, but what I want to start with is just think about if you were going to graph that, where would 908 degrees go? So remember, this is 0, this is 90, this is 180, and this is 270, and then to get all the way back is 360. So where is 908 degrees? So it's kind of crazy, but what you have to do, and if you want to kind of like write this off to the side just to remind yourself, you're just taking your original number, 908, you're trying to figure out how many times around the circle you went. So I'm going to subtract 360, which gives me 548. That's still bigger than 360, so I'm going to subtract another circle. I'm just trying to figure out what angle this really actually is. 188. Okay, so 908 degrees is actually 188 degrees, but in addition to two different circles. So where does 188 degrees go? Well, I start here on 0. That's my first part of my angle, my initial side, and I'm ending down here just past 180, so 188 degrees. And that is where that angle measure goes. So it's kind of like in a foreign language, like 908 degrees, what actual angle measure is that? You just keep subtracting 360 until you get a number that's between 0 and 360 so you can actually graph it. That's all you're doing. Okay, so number 8, the last one, I will save number 9 to talk about in class also. But negative 75 degrees. Maybe you remember, and maybe you've learned before, I'm not sure what a negative degree measure is. Negative 75 degrees means instead of moving clockwise or counterclockwise around the graph, you're actually going to go clockwise. So negative just means go the other direction. So again, we still have an initial side and a terminal side. My initial side is here, but negative 75 degrees is down here. And so another way to figure out what angle measure that is, so what if I wanted to be like in standard position, what is this measure? So what is negative 75 degrees really? All I'm doing is I'm taking negative 75 and I'm going to add 360 degrees to figure out where that is like in positive terms. And that gives me a 285. So that's the coterminal angle with that one. So it's like giving you a weird angle and asking you to figure out where to graph it. Negative means go backwards. If it's a huge angle like number 7 that we did, that just means keep subtracting 360 until you figure out how to put it onto a graph. Okay, that was a lot of new info. I'm aware of that. We will have time to ask questions and go over stuff in class tomorrow. Plus, we're going to do those 2 problems that I skipped, okay? Thanks for watching. Have a good night.